Today we are going to learn about mastering event time in stream processing. We will explore how to effectively handle event time, understand its importance, and implement event time processing in stream processing applications. Event time is a critical concept in stream processing, referring to the time when an event actually occurred. This is distinct from the time the event is processed in the system. Understanding event time is crucial for achieving accurate and meaningful data processing in real-time systems. In this video, we will delve into the intricacies of event time, exploring its significance and implementation in stream processing applications. By the end, you will have the skills needed to handle event time effectively, ensuring your systems process data accurately and efficiently. To begin our journey, it's essential to differentiate between event time and processing time. Event time is the timestamp attached to an event when it occurs, such as a click on a web page. In contrast, processing time is the timestamp when the event is processed by the system, which could be moments or even hours later. This distinction is vital because relying solely on processing time can lead to inaccuracies, especially in systems where events need to be analyzed in the order they occurred. For instance, in a financial transaction system, processing events out of order can result in incorrect balances. By prioritizing event time, we can ensure the data reflects real-world sequences and timings, leading to more reliable and actionable insights.
Implementing event time in stream processing comes with its own set of challenges. One of the primary issues is handling out-of-order events. In distributed systems, events can arrive at different nodes at varying times, making it difficult to maintain the sequence. Another challenge is dealing with late data, which can occur due to network latency or system delays. This can lead to incomplete analysis if not managed properly. Moreover, the complexity of implementing event time can be daunting, requiring sophisticated algorithms and careful resource management. These challenges can impact system performance, making it crucial to adopt efficient strategies and tools to address these issues effectively.
Fortunately, several tools and frameworks have been developed to support event time processing effectively. Apache Flink, for example, offers robust mechanisms for handling event time, including watermarks and triggers. Similarly, Apache Kafka provides capabilities for managing event time through its event streaming platform, allowing for scalable and fault-tolerant processing. Google Dataflow, part of the Google Cloud Platform, also supports event time, offering seamless integration with other cloud services. Each of these tools comes with unique features and benefits, making them suitable for different use cases and environments. By leveraging these tools, developers can simplify the complexities associated with event time processing, ensuring their systems are both efficient and reliable.
One of the most critical aspects of event time processing is handling late data and out-of-order events. Late data refers to events that arrive after a certain threshold, potentially missing the window for processing. To tackle this, systems can use buffering strategies, holding events until a complete picture is available. Similarly, managing out-of-order events requires mechanisms to reorder events based on their event time. This can be achieved through sorting buffers or using sophisticated algorithms that can dynamically adjust to incoming data. These techniques are vital for maintaining data accuracy and ensuring the system's analysis reflects the real-world order of events. Incorporating these strategies into system design is crucial for achieving reliable event time processing.
Watermarks and triggers are essential concepts in event time processing. Watermarks are a mechanism to track the progress of event time in a stream, providing a way to handle late data. They act as a threshold, indicating up to which event time the system has processed events. Triggers, on the other hand, determine when results should be emitted from the system, based on event time or data conditions. Together, they ensure that processing is both timely and accurate. For example, in Apache Flink, watermarks are used to manage event time windows, while triggers can be set to emit results when certain criteria are met. Understanding these concepts is key to mastering event time processing, as they provide the framework for efficient and accurate data handling. To put theory into practice, let's look at how Apache Flink handles event time processing. First, you'll need to set up an Apache Flink environment, either locally or in the cloud. Once set up, you can begin implementing event time by defining event time characteristics in your data streams. Flink allows you to assign timestamps and generate watermarks, helping the system understand the flow of event time. You can also set up triggers to determine when to process and emit results. For example, in a retail transaction system, you might use event time to analyze sales data, ensuring that all transactions are processed in the correct sequence. By following these steps, you can effectively manage event time in your applications, leveraging Flink's powerful capabilities for accurate and efficient data processing. Mastering event time processing requires adhering to several best practices. First and foremost, prioritize event time in your system design from the outset, ensuring that your architecture supports accurate event sequencing. Choose tools and frameworks that offer robust event time management capabilities, such as Apache Flink or Google Dataflow. Implement robust buffering strategies to handle late and out-of-order events effectively. Additionally, monitor and adjust watermarks regularly to ensure they accurately reflect the flow of event time in your data streams. Finally, continuously test and optimize your systems to accommodate changes in data patterns and system performance. By following these best practices, you can ensure your event time processing is both efficient and reliable, providing accurate insights and analysis from your data.
In conclusion, mastering event time in stream processing is crucial for ensuring accurate and meaningful data analysis. We've explored the importance of event time, the challenges it presents, and the tools available to support effective processing. By utilizing frameworks like Apache Flink, implementing robust strategies for handling late and out-of-order events, and adhering to best practices, you can ensure your systems are optimized for event time processing. With this knowledge, you're now equipped to enhance your real-time data processing capabilities, delivering more reliable and actionable insights from your data streams.